Hello students. So after a long time, we are meeting again. Today we are about to study motion in one dimension through graphs. That is, how do we study motion in one dimension by making graphs or studying the nature of the graph. So without wasting any time, we'll move further. So, beginning with the graphs, we know that the graph has two axes. One is the x-axis and one is the y-axis. X-axis is always taken as the horizontal axis and y-axis is always taken as the vertical axis. The point at which these two axes meet is known as the origin. In that way, we divide the graph paper into 4 parts. The first part or the first quadrant is known as the positive quadrant, where x is positive and y is positive. So the coordinate will be plus, comma, plus. As you know, the coordinates are always written in circular brackets. The first one is the abscissa showing the x-axis, and the second one or the next one is the ordinate showing the y-axis. Then we move to the next quadrant, which is negative of x-axis and positive of y-axis, that is minus plus. That makes the second quadrant. Third quadrant has both the things negative, that is abscissa also negative and ordinate also negative, that is minus minus, that is the third quadrant. And the last is the fourth quadrant, where y is negative but x is positive, that is plus minus, and that is the fourth quadrant. So these were the basics for a graph. While making a graph, you have to note these things, and you also have to write the scale of the graph in the top right corner of the graph paper. Without a scale, the graph is incomplete. So we move further. So the 3 kinds of graph which you have to study here are: number 1, displacement time graph; number 2, velocity time graph; and number 3, acceleration time graph. In all these 3 graphs, time will always be taken on x-axis, whereas the other one will be taken on y-axis. So, without wasting time, let's move further. So we begin with displacement time graph. In displacement time graph, case 1 is when the body is stationary. So the graph which we will get when the body is stationary is a straight line parallel to x-axis. The body is not moving, whereas the time is running forward. Therefore, we get a straight line parallel to time axis with the body stationed at a point. We could also have thought of that if the body has not moved at all, then what will be the graph? The graph will be a straight line showing the x-axis itself, because the displacement of the body is 0 and the time is moving forward. So we will get the graph as the x-axis itself. So the graph here is showing displacement time graph when the body is stationary at some point and has moved some distance. I would also like to mention here that a graph parallel to y-axis is not possible. Why? Because we cannot have a body which is making displacement without any lapse of time. So this case is not possible. Therefore, we cannot have a graph with a parallel line parallel to y-axis. So we move forward. Case 2 in displacement time graph is when the body is moving with uniform velocity. Now here in this graph you can see a straight blue line which is inclined to the x and y axis with an angle. This blue line is showing the graph of the body which is moving with uniform velocity. That is, the body is moving equal distances in equal intervals of time, and therefore we get a straight line. Now, if we have to calculate the velocity of the body at any point, we have to find out the slope of the body at the point. That means we have to choose any 2 points on the graph and we have to find out the slope from the 2 points which we have chosen. Here, for an example, I have chosen A and B. So A and B are the points. So we take out the coordinates of A and B by looking at the red lines. We find out what is the abscissa and ordinate for A and what is the abscissa and ordinate for B. And the formula for looking for the slope is y2 minus y1 upon x2 minus x1, where x1 y1 is A and x2 y2 is B. So we get the slope and that will be the velocity of the body moving. So we move further. In this graph, we see that the body is moving from A to B, then B to C, then C to D. Now from A to B, we have already studied that body is moving with uniform velocity. From B to C, also we have studied that the body is stationary. That means the body is stationed at a point and the time is running. The last one, from C to D, is that the body is moving with negative displacement. Now, you know, displacement is a vector quantity. That means it depends upon magnitude as well as direction. The moment the direction of the body changes, displacement is negative. So, if the body was moving in a forward direction and at some point the body changes its direction, the body moves with negative direction and so the displacement becomes negative. So in this case, the body is moving with negative uniform velocity and that is why the slope is coming down. So from C to D is the case when the body is moving with negative uniform velocity as shown in the graph. So we move further. Now, this is the case when the body is moving with variable velocity. That means the displacement moved by the body is different in the same intervals of time. So body is moving with variable velocity. So we get the graph as a curve. And if we have to find out the velocity at any point on the curve, we have to draw a tangent. Now, what is a tangent? Tangent is a straight line touching the curve in one and only one point. Tangent is perpendicular to the radius of the curve when it is a complete circle. So, by drawing a tangent to any point on this line, on this curve, we get the slope of the curve, and we can find out the instantaneous velocity at that point. That is the velocity at that instant. So we move further. So now we come to velocity time graph. Now this graph shows what all can be calculated from a velocity time graph. Number one is the acceleration from the graph. How? By getting the slope of the graph. The total distance traveled. How? By finding the area covered by the graph with time axis, and we can find out the average speed and average velocity when we know total distance traveled and total displacement traveled from the graph. So, moving to the values over here, if you see the graph closely, you'll see that the body is moving with some velocity, then it becomes constant, then velocity becomes negative because the direction is changing, and then it moves with negative velocity and it completes 1 minute, that is 60 seconds on the graph. So A, how to find out the acceleration in first 10 seconds. Now acceleration, you can see, is 6 by 10 over here, and so it comes to 0.6. Now how is it 6 upon 10? Now you see the slope is to be calculated here, so you have to see the y-axis. It is y2 minus y1 upon x2 minus x1. So 6 minus 0 is 6 and 10 minus 0 is 10. So it becomes 0.6 meter per second square. Now the second one, the total distance traveled by the body. So distance is, you have to find out the area covered. So total distance you have to find out. So half into 10 into 6, the first triangle, half base into height, plus the rectangle, that is 6 into 20. 20 seconds is the time lapse. So rectangle is 20 seconds into 6. Plus half 15 into 6. 15 is the time gap and 6 is the height. So half into 15 into 6. Plus half 15 into 6 with the negative velocity as we are calculating the distance. So we will see the distance adding the velocity, not subtracting. While when we are looking at displacement, then yes, the direction matters, but while calculating the distance, the direction does not matter. So there is no negative and positive in case of distance. So the distance traveled is 240 meters. Now we come to total displacement. So the first case, what we got from the total distance, that is half into 10 into 6, that is 30. Then 20 into 6, that is 120. Then half into 15 into 6, that is 45. And then here we are subtracting the red part, that is half into 15 into 6. And therefore we get 150 meters. Now average speed is total distance upon total time. So that is 240 plus 60, that is 4 meter per second. And that is 240 divided by 60, that is 4 meter per second. And average velocity, that is 150 divided by 60, that is 2.5 meters per second. So you have understood from here that how can we calculate different things from this graph and what can we calculate from here. So we move further. Now, these two graphs are showing the general velocity time graph, in which the velocity time graph is covering some area showing the displacement covered by the body. Now we begin with the cases in velocity time graph. The first case, when the body is moving with uniform velocity, that is, the velocity is same with the time moving, so we get a straight line parallel to x-axis. And here, two things which we can calculate. The first thing is the acceleration, which is 0 as the body is moving with uniform velocity. And second thing is the displacement covered by the body. So if you have to calculate the displacement from A to B, so we will see the area covered by the graph from point A to B with time axis, which is showing as a rectangle. So if we find out the area of this rectangle, that is length into breadth, that is the time axis into the y-axis, we will get the area of this graph, which will show the total displacement covered by the body. So we move further. Now, case 2, when the body is moving with uniform acceleration, that is, the body is a slanting line and making an angle with the x-axis, that is, the body is moving with uniform acceleration. Uniform acceleration means that the change in velocity upon time interval is changing the same. So, the body is moving with constant acceleration, so it is having a slope. And the negative side where the slope is steeping back to x-axis, that is the uniform retardation. So the body moving with uniform acceleration is when the slope is going up, and uniform retardation when the slope is coming down. Now, case 3, when the body is about to fall from a height, obviously the speed or the velocity of the body will start increasing because of gravity. As it will be approaching towards the ground, the speed will keep increasing. So when the body is coming from a height, that means it is falling from a height with an increasing speed, hits the ground and moves up, the graph is given in the way as it is shown in the figure. That means for some time the body will move with positive velocity, that is moving in one direction. Then as it hits the ground, it rises up again, so it will show a negative velocity as the direction is changing just opposite to what it was, and therefore we will get a graph of this kind. So we move further. Now here in this we have an acceleration time graph. Obviously time will be on x-axis and acceleration will be on y-axis. Now the kind of the graph which we will get when it shows the x-axis itself, the cases will be if the object is stationary, that means acceleration is 0. So we will get the time graph as x-axis itself. The red part is showing the same. If the body is moving with uniform velocity and the velocity is positive velocity, that means it is moving in one positive direction. Again, the acceleration will be 0 because there is no change in velocity. So positive velocity, it will again show a straight line. That means there is no acceleration. Negative velocity, maybe the direction has changed, but still if it is uniform velocity, acceleration will be 0, and therefore there is 0 acceleration, so it will be showing the x-axis itself. And if the velocity is 0, that means if the body is not moving, then also it will show the x-axis itself. After that, If the body is having some positive acceleration, it will be a straight line to x-axis, straight line parallel to x-axis. If the body is moving with negative acceleration, it will be a straight line again parallel to x-axis, but below it, because it is retardation, that means negative acceleration. And we have already studied the cases of zero acceleration, again a straight line where the velocity is not changing or body is not moving or velocity is zero, therefore zero acceleration. We will study this in the further graph also. So let's see further. In this graph, case 1 is a straight line parallel to time axis, and that too to the positive of x-axis. So this is the case when the object is moving with constant acceleration. So we will have a straight line parallel to time axis, and that too towards the positive side. Case 2, when the object is stationary or moving with constant velocity, we will have zero acceleration, which will be shown by the straight line on the x-axis itself. We have studied earlier. And the third case is the case for constant retardation or negative acceleration. That is, constant negative acceleration is constant retardation is case 3. So now we all have understood that what is case 1, case 2, case 3. If the graphs of acceleration time graph is given as shown here, we will understand the movement of the body. So we move further. Now here we are about to study the graph of a freely falling body under gravity. The body is moving freely. So what kind of graph we will get when it is a displacement time graph for a freely falling body? That will be a curve as shown in the graph. The second will be velocity time graph. That will be a straight line as the increase in velocity is uniform. So it is moving with uniform increase in velocity. And the third one, that is acceleration time graph, will be a straight line as it was moving with uniform increase in velocity. So acceleration is uniform. Therefore, the body is having a straight line parallel to x-axis, that is constant acceleration. Now, why is the increase in velocity uniform? Because the gravity is applying uniform force, that is why the body is having uniform increase in velocity. So with this, we come to the end of the graphical representation of motion in one dimension. I hope you have studied. If you have any problems, please ask me in the comments below. I'll answer then and there. Till then, thank you so much. Take care. Bye-bye.